Hello, welcome to this lesson where we're going to be looking at indices. So before we look at indices and how to use them, we're going to look at the different parts that are involved, or the different names that we use. So in this case, we have 9 to the power of 4, and here 9 is our base. So that's the number that we're going to raise to an index, power, or exponent. So this part here is our base, and the thing that we raise it to is an index, or a power, or an exponent. If you can remember all of those words, that'll be very helpful for you. Next, we have a few different forms that we could have our numbers in. Firstly, we have our index form, or our index notation, which is where we have a base raised to a power. Or we could have multiples, so we could have 3 to the power of 2 times 4 to the power of 6. That would be an index form as well. Next, we have expanded form. This is where we write it out as long as it can be. So we had our 3 squared times 4 to the power of 6. We're going to have 3 times 3 times 4, 6 times. I think that's correct. 1, 2, 3, 1, 2, 3. Yep. And then finally, we have the final number. And in questions, we might be asked to simplify. So if we're given something in expanded form, if we're asked to simplify, it means to collect our like terms and put it into index form or notation. If we're asked to expand, and not expand, evaluate, sorry, this is where we find out the final number. And you could find out the final number for this one. I'm not going to bother in this case. Okay, so here we have a few simple questions relating to indices that we're going to have a go at. So evaluate, it's often easy for us to put it into expanded form to understand these questions. So 4 cubed becomes 4 times 4 times 4, which is going to become 64. This one we can evaluate. I'm not going to put it into expanded form because I know what these powers become. We get 8. So we get 16 times 16, which is going to give us 256. Now let's just simplify 1, 2, 3, 4, 5, 6. We have 6 nines, so we're going to put 9 to the power of 6. This number here is just the number of times that 9 appears in this operation. Writing this one in expanded form, we want it like this. So we're going to have 2 plus 3 times 3 plus 4 squared becomes 4 times 4 times 2. Now when we evaluate, we need to remember our order of operations. So our brackets, indices or exponent or operation, power, division and multiplication, and then addition and subtraction. So we have these different stages we need to go through. There's no brackets, so we go on. We have our indices, so we're going to go 2. We're going to evaluate 3 squared, which becomes 9, plus 4 squared, which becomes 16 times 2. Now we go into multiplication. We get 2 plus 9 plus 16 times 2, which is 32. And then we're going to add that all up, and the final answer is 43. Now it's your turn. Answer these questions one by one. The first one we evaluate, we get 9 times 9, which is 81. We evaluate the next one, we get 5 to the power of 3, which is 125, times 1 to the power of 4, and 1 raised to anything is just 1. So our answer there is 125. Next we have 6 5s, so we go 5 to the power of 6. Now in expanded form, we just write 3 to the power of 3 becomes 3 times 3 times 3, plus 2 times 2 to the power of 4 means we have 4 2s, and then minus 9. And then with evaluate, we need to use our order of operations. So we start with our indices here. So we're going to get 27, so that equals 27 plus 2 times 16 minus 9. And then we go to our multiplication, 27 plus 32 minus 9, and then finally 50. We also see indices used when we're talking about the factors of numbers. And this is something that you would have looked at in year 7, but we're just going to a bit more complex of a level. So we're going to draw a factor tree for 24 to find its factors. So we could go say 6 and 4. Then we get 3, 2, 2 and 2. And if we were to write out its factors, in expanded form we would get 24. So I should write 24 equals 3 times 2. So just multiply all of these prime factors here. So we get 3 times 2 times 2 times 2. Now that we know index form, we can rewrite this as 24 equals 3 times 2 to the power of 3. So it's just like what you've done in year 7. All this we would have seen before. This just helps us to write it in a more succinct way. Okay, so now have a go at drawing the factor tree for 100 and then writing out the multiplication of its prime factors in index form. Okay, so we're going to go 50 and 2, and then I'm going to go 2 and 25, and then 5 and 5. So if we then write that, we get 100 in expanded form equals 2 times 5 times 5 times 2, so that's just all the prime factors. And then we can group those, so we have 2 2's, so we get 2 to the power of 2, and 2 5's, so we get 2 to the power of 5. So in index form, 100 equals 2 to the power of 2 times 5 to the power of 2. Okay, so here we have a multiplication being raised to a power. And using our knowledge of powers, that means we have AB times AB. We can then put our little multiplication symbols back in, and we get this. And then we group them, we get A squared times B squared. So we've got in the end AB squared equals A squared times B squared. And that's an important thing to remember. Now we're going to write this and use this formula to rewrite it. So we're going to go 3 times 2 to the power of 4. And then we have our A here, our B here. So we have 3 to the power of 4 in this case, times 2 to the power of 4. And it might be easier for us to work out this one in our head than this one in our head, which is why we do that. And then finally have a go at this question yourself. Okay, so we have our A and our B. So we're going to get 5 to the power of 3 times 3 to the power of 3. I hope that lesson has made sense. Here's a summary of what we looked at. Come and see me in class if you have any questions.